Fantastic pronunciation, by the way. That's very uncommon. So thanks to Hank and Peter and for all of you guys for coming. I did spend 10 years looking into synthetic cognition, but it's all predicated on my science undergraduate work and physical chemistry and my design practice. So I'm going to come at this from a little bit different perspective. I have a question for you guys. Anya brought up the spectrum earlier, and implicit in all the talks and in the spectrum that she showed is the idea that if we're going to do artificial intelligence, that it'll be on a von Neumann architecture, on a digital computer. How many people believe that's doable? That first of all, it's possible to do intelligence on a von Neumann machine? Okay, that's good. Now that someone just blurted out the requirement, but is it a requirement, or is there another possible machine? Not wetware, obviously, but like, is there other machines that could implement intelligence? Okay, see some nodding and some hands. Okay, all right. So one of the things we do as designers is, what I'd like to try and do is just step back and challenge some of our, as Fred was pointing out, with this portion of the brain asking questions. So when I started in on this, I was just really interested in the field, and I'll talk further later about some of the roadblocks I came up against. But I wanted to challenge preconceptions, because sometimes when you're going into a design problem, it's really complex. And if you're in the habit of preconceiving your solutions, you already have a preset preconception of what the solution is. A lot of times that'll lead to failure because the problems are very complex, and the worlds will have passed by those previous solutions, and so that you really have to have a habit of coming up with different ways to get to those solutions. So just to go through really quickly what the really great talks have gone through, I just want to sort of state where I stand, just to use those talks so you guys can maybe more quickly understand where I'll be coming from. So as I mentioned before, Anya, I just don't believe that my position is on the spectrum. I think that von Neumann machines will be part of the solution, but in the spirit of being inspired by our only proof of concept, wetware, so to speak, that it'll be a machine that's not only digital machines, and that like Gary and Peter to a degree were also saying, I think it's not so much a hardware problem as much as it is a theory problem, that we really need a theory, and that's where I hope to at least contribute. And I gave a talk at Monica's AI group a couple years ago about the schematic design I came up with after 10 years of work. I'm not really going to talk about that today. It's pretty technical and involved. And I think what would be much more appropriate for this, the subject of this symposium, is to go back and talk about what led to that schematic design. Like, what were some of the questions I asked and some of the inspirations that brought me to those conclusions. So, just to be clear, I believe that artificial intelligence, well, I hesitate to say AGI because I want to respect Peter's definition of it. I think that what I'm really talking about is some of the steps to get to AGI, what I'll call proto-AGI. But I think it's totally doable. But I think that we really need to reframe some of our assumptions of how we get there. Some of the assumptions that we just take for granted, like using von Neumann architectures. So as was mentioned, I work for the Exploratorium, and a key aspect of being human is this instinct of exploration and increased understanding. This instinct is because we have a mind, but that exploration is also how we sustain our mind and its vitality. Ever since I was a kid, I've been really interested in how the mind works. but my path to understand minds and their creativity has taken a circuitous route, as I'm sure you could imagine, given my background. As already mentioned, I studied physical chemistry and then went on into design. But after my undergrad in science, instead of drilling down into the reductionist approaches, I found that intuitively that a architectural design practice would let me really delve into the complexities of real-world problems without sort of looking at the world as a model. So I agree very much with Monica that we need model-free methods, and I agreed with Peter on something else, but I forgot. So after design school, I did the police station, which was already mentioned by Hank, and then we won some design awards, which was great. I was 20-something, full of myself, and thought, well, geez, maybe I could answer the question of how we're creative at all. Not that I was harboring a little hubris or anything. I really, to be honest, didn't know what I was talking about, but it was enough of it excited me enough that it sent me on a 10-year journey. So I want to talk a little bit of that journey to try and justify some of the claims that I'll make about ways to move forward. So again, like, how are we creative at all is the fundamental question. And then 9/11 happened, and then the how question became more of a why. Like, why are we creative? And furthermore, why is it that nature has preserved both creative behaviors in both us and many other animals, but also destructive behaviors? And is that just an accident that both those creative and destructive behaviors were preserved, or is it actually necessary? And I really wanted to delve into that seemingly difficult question. So I entered the memorial, as again Hank mentioned, and let's see if I can get my arrows correctly. And then I did this competition, which its centerpiece was an interactive art piece that would interact you in such a way that its intent was to people who go down to the 9/11 site where the buildings fell, in a way to try and help heal the divisive ways that humans can sometimes interact with each other, that it could be that through technology it could be an integrating force, a harmonizing force. And so I thought, well, if you could have a bunch of people coming around at different times of the day with different crowd patterns, that this system through infrared and ultrasound and different senses be able to absorb and record those patterns, that then those patterns could be mixed in some way, integrated, and then played back. And then through sort of an evolutionary process, we've talked about sort of evolutionary notions of how we think. Through an evolutionary process, some patterns would be selected for over others based on whether it encouraged crowds to stick around or to come around. So that was sort of the selective pressure, if you will, is that if some pattern that was generated by past crowd activity was able to keep a crowd, then it would tend to be selected for. So this is a little bit more descriptive diagram, and diagrams can be deceiving, conceiving. That where the this is an example of so this obelisk here would be here, and then there would be a sensor array that would be in the surrounding area. So it would sense as you came in and as you went out, how people moved, how quickly they moved, their heat signatures, etc., what sounds they made, and then all that massive amount of information then would go into what I called this memory root, and then perform this integrative process display, and then have that selection routine that I mentioned. Simple enough, right? Well, as Monica mentioned, I mean, all that massive amount of data is not a trivial. Just to absorb it and record it is hard enough, let alone to synthesize it in a way that was useful. So this this begged a lot of questions because once I started in on this, and it begged the question, this so-called black box, the memory root, is like, all you got to do is, we have this saying at the Exploratorium, like, if anyone's, one of your engineers or designers says, all you got to do is, you pretty much call them on that immediately and say, yeah, you have no idea what you're talking about, because it's just code word for trying to convince you that it's quite simple and trivial, when in fact it's not. So then I started digging into what was available at the time to do this work. And so functionalism. So the first stop on the AI story, and I won't belabor this because Peter and others have given a good history of where AI has been and where it is now. But functionalism is essentially, there's an input, there's a fixed function, and then there's an output. And I just felt immediately dissatisfied with that as a way forward, because fundamentally, when you look at how a logic gate works, is that it's dealing with discrete states, and then you're essentially collapsing these discrete states into those discrete states, and you can deal, it's sort of the culmination of the Industrial Revolution, in the sense that you have these sequential mechanistic parts that have perfect fidelity. In other words, you've used a lot of energy to maintain, for all intents and purposes, perfect accuracy and perfect state retention. But intrinsic in that is a problem, and that's the problem of synthesis. That this tool, to my mind, 10 years ago, seemed from the get-go ill-equipped to do synthesis, which is essentially one of the main goals that I wanted to achieve. Then I went to neural networks and became very excited about their potential. But again, I felt that that it was a similar outcome, in the sense that you spent a fair bit of time training these networks, and there's an input and then some hidden layer and then an output. Well, essentially that hidden layer becomes the function. It just becomes that function over time, and then it becomes relatively fixed. Furthermore, something that I think deep learning is trying to grapple with to some degree of success is, how do you scale? How do you generalize? How do you get that hidden layer to interact with other hidden layers in a way that doesn't lead to both computational explosion and other research explosion, like memory and computational resources that need to store those hidden layers as they accrue. And they will accrue as you try and synthesize. All right. So this led me to a deeper thought about questioning what information is. And this is really sort of the crux for me that I hope to convince you guys of by the end of the day. And where that leads is, I'm not going to make any huge assertions about that today. Again, that talk I gave at Monica's AI group delves into a schematic design of the implication, the implementation implications. But for now, I just want to try and communicate that our notion of information is incomplete, and that when we use the term information, whether colloquially or within the context of AGI, we actually mean something quite different than the Shannonian notion of information. Does everyone know, like, Shannon information? Does that relatively, okay, a couple. So basically, Shannon information is more of a tool to talk about, let me step back from that. So in the context of what I said before, there's a notion of information as these discrete states, these atomic facts. So then the other side of information that I want to try and convince you guys of is the more integrative aspect of information. In other words, in order to render any sort of event in the world meaningful, whether to us or some other agent that we create, that agent has to synthesize patterns, stimulus, into complex, constructs. Complex interrelations between those states. So this is what I call the paradox of information, because because there's two simultaneous things going on here, and I want to get the verbiage right because it's not the simplest of concepts. So so the more general understanding of information presents something of a paradox. How can something be both distinct, like those ones and zeros, that can distinguish, for example, some physical phenomena from its surroundings, like a signal in the noise, and be about interrelations amongst those signals? These two attributes seem to be orthogonal to each other, yet it is just this tension between being and becoming that anything is significant to us at all. So put another way, all that is meaningful to us, that which is relevant to maintaining our sense of self, seems to rely on two opposing attributes of existence: that which is discrete and local, and that which is continuous and distributed. Our world simultaneously grants us autonomy and uniqueness, while we have no existence without a wider context to exist within. So I'll say more of that. I understand that sounds a little poetic, but I'll dig into that a little more deeply as I go on. So this is to summarize general information that, and to provide sort of an analogy with the drops on a pond. It's simultaneously the distinct events, for example, each individual drop on a pond, but it's also their interrelations, the ripples that interfere, and that to begin to build from distinct events to ever more complex interrelated distinct events, there needs to be, I would suggest, it helps at least from an design engineering perspective, that it's more efficient to have some medium that's really readily, that's immediately ready to handle both of those aspects of information. So this is sort of a familiar idea to some of you. That it's sort of just a restatement of this paradox, the paradox of parts versus the whole, because often it happens that far from the paradox being a roadblock, it is in fact a signpost for a deeper, more general solution. And again, this is sort of a trick that designers use when they're dealing with very complex problems, is that you almost revel in the contradictions, and in the tension is the solution to handle the more difficult projects that you're trying to essentially have a number of different constraints and like budget and space. And they're kind of against each other. They contradict each other. So how do you look at those tensions and find the overlapping areas where you can come together as a whole without necessarily just using more resources? So then I asked myself, could nature have evolved a dynamic system able to take advantage of both of these aspects of information simultaneously, so that agents can adapt to their indeterminate worlds with ever broader success over time? So going back to the VDL, so, and again, this is sort of how design works. You make a goal, and then you start digging into that goal, looking at the ramifications and the constraints and the things in your way, and you realize that your goal might need to be modified a little bit. And so based on this desire to leverage this paradox, I began to realize that my original intent for this art installation was a bit hand-wavy, and that essentially it itself was a goal function. And that's not what I wanted. Like Monica talked before, like a goal function is, it can over-cohere on a local minimum. In other words, it would select for only very sparse number of patterns, and that's not what we're looking for in a general AGI. So I realized that my intent was, like I said before, maximizing a maximizing strategy, like a functional approach, and that it too would tend to over-cohere on particular patterns. So put in evolutionary terms, selection for a few well-reinforced traits is but a part of the process. Becoming sensitive to a great variety of potentially relevant patterns, and then finding the relations between them in the world without preconceptions is another critical piece. So in other words, the way I conceived of this project in the beginning was it's like, okay, well, I'll just select for some patterns, and then when the crowd sticks around, it would just essentially be a reinforcement function. But I realized that in order for it to truly be a robust response to a complex environment, I need it to have what in evolutionary theory is called requisite variety. In other words, it needs to select for not just the most popular thing, but also be able to absorb some of the quieter patterns in the environment that then could be used to add to its richness, even though those more quiet patterns, those less frequent patterns, weren't necessarily for the goal function at any given moment. So it's this second attribute of agency that really lays the foundation for our continued learning in ever more complex patterns. This realization led to a new, not goal or function, but an ever-evolving behavior, just like life in general, a more general behavior I call augmentation. So to create an art installation that truly invents ever more complex behaviors inspired by its surroundings, I began to think more deeply about how learning is augmented, not in spite of the paradox of information, but because of it. So in other words, not in spite of the fact that it wants to simultaneously collect a lot of distinct events, but also be able to relate those events. How is the complexity of the world a feature to be explored and not a bug to be filtered or averaged out? So first of all, what is augmented learning? So augmented learning is the capacity to learn not just singular things, like I said before, but many things and also how these things in the world relate. The relation among things is fundamental to understanding how the world works. The world and its relevance to some agent is as much about interrelated causality as much as it is about distinct objects and events being recorded accurately. So this is just a restatement of augmentation put informally, the ability to assimilate many distinct patterns and the relations between them. And then there's a follow-up, and to increase the capacity to do adaptive work in the environment. So what does all that mean? Okay, so let's walk through a possible agent that's trying to take advantage of all that's already available in the environment, the complexity that's inherently there and potentially relevant. So on the x-axis, we have time starting from inception to death, and then on this vertical axis I have what's called relevance. And relevance I define as composed of two main things. One is complexity. And what complexity is embodying is essentially what I've talked about so far, is the ability to assimilate not just distinct states, but also the interrelation between states. And then the other aspect is the ability to do some kind of useful work based off of that structural complexity. So a lot of people have talked about before, like at the internal structure of the system needs to be reformed over time. So the question is, how does it reform in such a way that it can respond in the future to stimulus that become ever more complex in such a way that it can do more useful work in the future. So for example, red color, smooth round shape, the size of a fist, and crunchy taste are all distinct patterns that taken as a whole are an apple. These attributes, as they co-occur, are learned both separately and together. The child's knowledge of the world is expanded because both the parts and the whole coexist. The many diverse patterns that mold the internal structure of our agent are the foundation upon which more complex patterns are synthesized, creating the basis for more complex and adaptive work behaviors. So just to put a finer point on it, and this is partly where the elephant in the room rears its head a little bit more explicitly, what I've discovered is that when you try and implement this with an actual machine, is that as you're trying to assimilate new patterns and then integrate them into this more holistic approach, like throughout the day, this Imagine agent would be absorbing information, but then it reaches a point of saturation where it becomes fatigued. Because essentially you can imagine the more information you absorb, you're overloaded with sort of this silo effect where you have a bunch of information like atomic facts about different things, but then how do those things come together as a whole? Well, that's a whole nother process. So what I've postulated here is that analogous to like a wake-sleep cycle, that you literally have to shut the stimulus input down so that the system can sort of revel in the chaos that's been produced throughout the day with the absorption of new information. So then if you string this sort of the increasing amount of chaos and noise over the course of absorbing information, you reach a fatigue point, and then you shut down that sensory input, and then that I would argue is almost required to then reform the new information against existing information. So it's kind of like an analogy would be if you wanted to remodel your house. A lot of times you have to demolish a part of the house in order to add something new, a new conception to it. So that's if any of you ever gone through a remodel process, it's actually really chaotic. You have a bunch of demands, like your family size is getting bigger, and that pressures you to literally tear down that which before served you quite well. And you willfully go into this chaotic process so that then you can rebuild in the image of new forms of work. But in order to do this, it's sort of this paradoxical process of willfully engaging chaos in order to remake yourself in a new way, and then this if it's in a cycle can then ratchet itself, so that augmentation, as I informally defined before, can be more formally defined as this curved regression right here. In other words, this ratchet, the average of it over time is augmentation. All right. So, once again, back to my design competition. So this is just one step further in the black box of imagining how you could come up to this system, and that over time it would be able to assimilate not only many diverse patterns, but then literally come up with completely novel patterns that were synthesized by itself, so that it literally does have a sense of agency that you can't preconceive. So it would be similar to your child that would take a common pattern that it picked up from you, but then apply it in a completely novel context. And a lot of times we laugh, we find that very humorous, because if it's not completely absurd, sometimes it actually tells us something unique about this phrase that we've used and taken for granted for years. So this is just drilling down just slightly into the how of it, and it's just a little bit of a teaser. Like I said before, that I gave the how talk to Monica, and that's available thanks to her very skillful and gracious filming online. So I really encourage you to go check that out if you're interested in a possible implementation of that. I do suggest that, just again from an engineering point of view that both the digital, that accuracy and stableness of state is very great for one aspect of assimilating useful complexity in the world, but that to get the other aspect, that an analog, nothing exotic, but an analog portion would be quite useful, and that the hybrid of the two, you sort of get the best of both worlds, could really move the project forward. So, to the questions of the conference, how long? Well, I'll go out on a limb and say, 30 years, which, is sort of the pat answer. But I put a pretty strong caveat on that, and that caveat is that in order to get that 30 years, in order to achieve not necessarily AGI, thank you, not necessarily AGI per se, but a proto-AGI, a proof of concept to show that we're on the right track for AGI with an actual empirical feedback that we are creating autonomous machines that are able to learn on their own and actually show us aspects of the world that we hadn't preconceived. In order to do that, I really do think that I'd argue that we need to reframe the question, that we need to reframe our assumptions about what is information, what is complexity, and why would we go about developing autonomous agents. And that, in fact, as I mentioned, the question that I started with, is creation and destruction a necessary part of the system? And I would argue yes. That like artists, like sculptors, we need to sculpt the balance between creation and destruction in this proposed machine or some other pathway, but that they both need to be respected and leveraged in an integrated fashion in order to achieve our eventual AGI goals, but that if we accept this premise, and well, not just we, but if a critical number of funders and AGI researchers accept this premise, that then within 30 years we could come up with a prototype for a proto-AGI. So for the risks, all right, again, assuming this new approach that's reframed, it already puts us, I would argue, closer to what we already have up here. And therefore, I might disagree with Peter a little bit, and I think it's sort of an academic point, like which comes first, the standalone AGI or the cyborg. I think they'll both happen eventually, but I would suggest that if we go this route, that we'll end up with the cyborg more quickly, because essentially this theory of augmentation brings us more close to the order and disorder that's managed by our evolved brains, and that it would just be a lower hanging fruit, and that we could reach augmentation much more quickly than we could a standalone. But then eventually we'd begin to master, the technologies would come up, and we'd begin to master different aspects for an actual standalone system. But that's all to say that if you grant me the cyborg route, then we can take comfort in knowing that the advancements in horrors will be both familiar and our responsibility, and we can be equally afraid knowing that the advancement in horrors will be both familiar and our responsibility, because essentially we will be them. There will be no us versus them. It'll just be a more augmented extension of our tendency to create and destroy. So, thank you very much for your attention. And are there any questions? Yeah.
Regarding my questions with Fred earlier about senses, wouldn't the cyborg, if I understand that correctly, the blending of a machine and a man, deal with the problem of the lack of senses? And also it seems to me that is the goal to try to give machines their own values, in which case you're trying to make another type of human? Or do you want an external human controlling
Yeah, well, to take the senses first, I mean, I agree with Peter that you could have a minimal number of senses to achieve an agent, a proto-AGI that could be useful in the world, both to us and itself, but that you still need senses. The cyborg situation it augments our evolved senses. It might give us new senses, but that I would suggest that really the reason why we don't have even more senses is because the evolved wetware just can't handle that much more synthesis, because like I was arguing, the synthesis is just a critical part of the information input as the information input. so that if if our strategy doesn't handle the synthesis, it can't handle senses. But having said that, the more senses you can take, they're essentially like unique perspectives. So each sense, if it can be correlated and then move on to causation with other senses, then you can more accurately model and therefore create more potential for adaptive work. Now, in terms of values, I think that, and this is where I sort of pull the designer card. Like, as a designer, I don't go out in the world and impose my values. My job is to let the values evolve as an outcome of delving into the tension between the competing constraints. So what I mean by that is that there's kind of an ambiguous goal in the beginning. We want to achieve X, Y, and Z, and then there's all these competing constraints that are in the way of achieving that goal. Now, as you delve into the constraints, what happens invariably is you discover affordances and opportunities that you could never preconceive if you hadn't rigorously delved into the tension between those constraints. And then you get not only an evolution of yourself, your understanding, your knowledge, both epistemically and maybe even ontologically, but you also get an evolution of your values, because clearly, I would argue, I think we'd agree that our values back in human sacrifice days were maybe less evolved. Just go out on a limb. Yeah, Peter.
Yeah, Josh, I'd like to understand a little bit better exactly whether there's a need for analog design or whether that's just a convenience. I certainly started out as an electronics engineer, so I'm very sympathetic to that. But I don't really understand why augmentation or chaos or any of those things require analog. I mean, we can create plenty of chaos in digital systems.
Absolutely, yeah. So I think that it could just be a limit my own understanding. That I just was taken both by digital. I mean, I really delved, after I had this inspiration, I delved into both digital and analog electronics, and found beauty in both of them. And then it was just a question of, well, geez, if I'm an engineer, if I'm a designer, and I want to achieve these behaviors that I've outlined, it was really more efficient, I found, to use the benefits of both and integrate them in such a way where both their strengths are utilized to reinforce each other. So if there's a way to use purely digital to achieve that, then that's great. It's just I found that seemed to be a more efficient pathway, given my understanding.
My question is a little bit different than everyone else's, but so if using the theory of augmentation, if we can achieve cyborgness before we achieve artificial intelligence machines, then do we still have a purpose for AI? What's the benefit? Maybe you can compare and contrast cyborgs and standalone AI. Absolutely.
Yeah. I think that the answer is, I would suggest, is yes. That I think there will always be, like any tool, and I use the term tool very carefully, and because a tool, so in evolutionary theory, there's this something called exaptation. So in other words, what that means is that some morphological part of a body has evolved for a particular function, but then the environment changes, and instead of just that becoming a vestigial structure, it actually gets used for a completely different function. And so that sort of simultaneously works towards the idea of a tool, but simultaneously it challenges it, because a tool, by definition, by some definitions, is only as good as it performs its pre-described function, right? So as soon as a shovel starts stops shoveling, then it ceases to be a useful tool. So to your question, I think that we are all, and this is it's kind of a tautology, like with our tools, we're all co-evolving to then do with the requisite variety, like the other evolutionary example I said before, like creating the requisite variety of tools in order to hopefully enhance our ability to persist on this planet. And I would argue that it would increase the chances of that persistence if we utilize all the possible tools. So both cyborgs and standalone AIs, I think, can be part of that solution.